Hello, everybody. All right, so today we're going to be looking at simplifying radicals and solving equations with them. Okay, and to start with simplifying, we're going to be not just looking at square roots like we have been all year so far. We're also going to be looking at cube roots, fourth roots, fifth roots, whatever root. All right, these rules just generalize. To do that, we're going to need to know not just our perfect squares like we know them already, like 4, 9, 16, 25, 36, etc. We need to know our cubes, like 8, 27, 64, 125, 216, etc. And we're going to need to know our perfect fourths. So 16, 81, 256, 625, etc. And even like sixth powers. So that would be like our fifth powers. So 32, 81 times 3 is 243. And then 256 times 4 would be 1,024, etc. So we can keep going. So they have the same properties of square roots. They follow all the same rules. So not a lot of extra rules to learn. We just have to adjust our brains. So for example, if we have like the cube root of x, like we do right here, right? That's asking what times itself 3 times equals x. So if I have the cube root of 64, I'm saying something times itself 3 times is 64. Well, 4 times itself 3 times is 64. We can take the cube root of negative numbers, so they don't behave like square roots in that way. And that's because negative 2 times negative 2 times negative 2 is still negative 8. The first two negatives cancel out, and we still have a negative left over, so it is negative 2. All right. The fourth root of 625. Well, what times itself 5 times is 625? 5 times itself 4 times is 625. And then with the cube root of negative 125, again, those odd roots, we can have negatives under without an I or anything like that. So just negative 5. In fact, the negative can kind of come out if you want, so you can treat this as like the negative cube root of 125 and go from there. Reason why you can do that is because you can split this up into like the cube root of negative 1 and the cube root of 125, and you know the cube root of negative 1 is 1. It's negative 1. So, but we can split this up the same way that we split up radicals before, right? So the cube root of 24, we can split that up into the cube root of 8 times the cube root of 3. The cube root of 8 is 2, so it's 2 cube roots of 3. The fourth root of 80, we can split up into the fourth root of 16 times the fourth root of 5. The fourth root of 16 is 2, so it's 2 fourth roots of 5. The cube root of negative 81, we'll take the negative out to start. That is the cube root of 27 times the cube root of 3. Again, you're just going to want these perfect cubes and stuff memorized. Circle all my answers. And then the fifth root of negative 6. Well, we can take the negative out, and I don't think I can simplify that other than that. So the negative should come out of odd roots. Okay. That's simplifying. But just like how you guys could solve equations with square roots, we can solve equations with other roots. So if we have an even root, we need to use a plus or minus. If not, if it's an odd root, then the sign matters, but that sign doesn't, we can take the root either way. So like the fourth root of 80, the x to the 4 equals 80, so I'm going to take the fourth root of both sides. So that'll cancel out. I'll get x equals plus or minus. I took an even root for the fourth root of 80. And 80 is 16 times 5. Well, the fourth root of 16 is 2. So it's x equals plus or minus 2 fourth roots of 5. And if I take the cube root of negative 81, x equals, take the negative out while we're at it, the cube root of 81. Well, that's cube root of 27, cube root of 3. cube root of 27 is 3. So x equals negative 3 cube roots of 3. There we go. Have a great day, guys.